Bubble sort is a simple sorting algorithm in C that audits and compares two adjacent elements to determine which is larger or maybe lesser and then switches them based on the given condition until the element's final position is found. Through this video, we will learn about bubble sorting using C programming language, using examples and implementation. So stay tuned and learn all that you can about bubble sort in C. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Bubble sort algorithm. Now let's try to understand what is bubble sort. Now before we understand that, let's try to understand the word sorting. So sorting is nothing but arranging your numbers or set of students with respect to what roll numbers. You're trying to sort them either in ascending order or in descending order, right? So it is one of the easiest and one of the brute force sorting algorithm. Now easiest is self-explanatory, but what do you mean by this brute force? It means straight forward, right? So it is a straightforward algorithm wherein we will be comparing first element with every other element in the array, right? So with this, we can either sort our array in ascending order or in descending order. Now, basically what we will be doing in this algorithm, we will also talk about its algorithm, time complexity and all those things, right? But here we can get a brief idea that we will be swapping elements and we will be swapping them in such a way that with each iteration, the last element that is there will be the largest element in the whole array, because we will be trying to sort our array in this video. We'll be sorting them in ascending order. Okay. So the last element that is present in the array will be fixed in the first iteration and it will be the largest in the array. And we'll be using or implementing this bubble sort with the help of nested loops. Now what do you mean by nested loops? That it means that we will have a for loop and inside that for loop will be another for loop. So this is what I mean by nested for loops. Bubble sort algorithm. So as you can see that in this algorithm, as I told you earlier when we were talking about what is bubble sort, in that I told you that we will be implementing this bubble sort with the help of two for loops, that is the nested for loops. So as you can see, we have two for loops. That is, this is the first for loop, which in this we will be iterating from 0 to n elements. That means if there are 5 elements, we'll be traversing from 0 to 4. So with that, every element will be compared with the rest of the elements. So that is done with the help of this second for loop, and don't worry about it right now. This I, why I'm subtracting I from n minus 1 and why n minus 1 I'm doing. Let me clarify it here, because we are comparing the jth element with j plus 1 element. Now when our j is at the second last element, that means if this is the array and let's suppose this is the array and j is here, the second last element, at the second last element it will be compared with this element. Now at the last step wherein if j would have been here, it would have been compared with the element which is not there, so it would have resulted in error. So to avoid that error wherein we will get this element, we are trying to access the element which is not there, we are subtracting 1 from n, so thus keeping it within the array, right? And what about this I? It will be covered in the next slide wherein we will talk about one example, and where there I will talk about this I, why I am subtracting this I again and again. Okay, now if our j is greater than j plus 1, let me take an array here. If j is greater than j plus 1, that means this element is greater, we swap them. And we swap them in such a fashion that after the first iteration that this loop does, the entire iteration of this loop, when this loop will be exhausted, the last element that is there will be largest element in the array. Okay, done. And then we will start moving to the next element, and we will start our iteration again from zeroth element, right? Because they would have swapped. Now, this might not be clear to you guys right now, but let's take an example and let's see how it works. So as you can see, this is our input array wherein we have 23, 10, 16, 11, and 20. So these are the elements in the array, and the index of this is the last element is 4. That means the end here, the size of the array is 4. Okay, done. Now that we know this is the array, now let's talk about the first iteration. So the outer loop will work from 0 to n, right? So that means the outer loop that I is at right now is at this location. And what about that j, the inner element? So that is this j. Where is it? Let's talk about that. So if you can see, j is right now at this location and it will be compared with j plus 1. Okay, so now what happens? So this 23 in this j and this 10 will be compared. So since 23 is greater than 10, we will swap them. That is what is happening, right? We will swap them if j is greater than j plus 1. So once we have swapped them, so you will get 10 here and 23 will be here. So 10 here and 23 will be here. Now we increment our j. So j will be here. Again, it will be compared with the 16. Again, it is greater than. So we have 16 here and 23 here. Now 23 is here and it will be compared with 11. Again, they will be swapped. So 23 will be here. Now, after this iteration, the last iteration, what happens? This 23 and 20 will be compared. These will be swapped. And at the end, we will get 23. Now that is what is done in the inner loop after the whole inner loop is exhausted, right? It is exhausted once, the inner loop. Okay, so this is what you get, right? It's 10, 16, 11, 20, and 23 at the end. Now what happens? I told you the one condition, that is n minus I minus 1. So n minus 1, why we are doing this? This is clear to you guys, just to avoid that error situation. But now this I, what is the value of this I in the first iteration? It is 0. So nothing will happen. So your n is 5, 5 minus 1 minus 0. Or if you have written this, it will be 5 minus 0 minus 1. That is 4. Okay, so the inner loop will work 4 times. First, it will be compared. This is the first iteration. This is the second. This is the third. This is the fourth. So 4 times your inner loop will work. Now, next time around, in the second iteration, our I is 1. Now this time around, what happens? It will be 5 minus 1 minus 1. That means it should iterate only 3 times. That means we will be comparing this element with this element with this element with this. Do we need this element to be compared? No. Why? Because this is the in the entire array, this is the largest element and its position got fixed during the first iteration. So that is why I'm keeping this n minus I minus 1 or n minus 1 minus I. It doesn't matter. Okay. So now this thing is clear to you guys why I'm subtracting this I. So now next time around, what happens? This 10 will be compared with 16. So nothing will happen because 10 is less than 16. Next time 16 is compared with 11. They will be swapped. 16 will be here. Next time 16 will be compared with 20. Nothing will happen because 16 is less than. So after the second iteration, you will get 10, 11, 16 and 20. So again, now you see this was not compared after the first iteration. Now after the second iteration, we will not compare this element, these two elements, because they are at their original positions. Now what happens in the third iteration? Again, let me go back first. So now what happens? Let me just clear the screen. So these two will be compared. These two will be compared. So 10 is less than, 11 is less than 16. So nothing will happen. So you will get 10, 11, 16, 20 and 23. In the fourth iteration, so now only these two elements will be compared. So nothing will happen and we will compare these two elements. And after third iteration, these will be the elements 10 and 11 and this. So after that, on the fourth iteration, nothing will happen and we will get our sorted array. So this is the whole demonstration of how bubble sort works. So your elements will be placed like a bubble. So after first iteration, the largest bubble that is there will be at its original position. After second, the second largest. After third, the third largest. After fourth, the fourth largest. After fifth, the fifth largest. So this way around, like a bubble, all your elements will be sorted. Now let's talk about bubble sort implementation. So this is the method wherein we are implementing our bubble sort. In this method, we are the first argument that is there is the array. That is our array. That is this array. Wherein let's suppose we have 0, 1, 2, 3, 4, 5, 6, and then 2, 3, then 4, then 1, 9, and 0. These are the elements in the array. And the size, now this is very important. What are you passing? Are you passing n minus 1 from the driver method that will be there? Are you passing n minus 1 as your length, or are you passing n? So it depends upon what you are passing. Okay, so let's suppose I am passing the size, that is the length of the array, which is we have index 6, that means 7 is the length of the array. I am passing that 7 here. Okay, so size is 7. So now accordingly what I will do, let me just clear out this screen a little bit, and let's go and debug it. Okay, so now what happens in this outer loop, so index I is referring to this index, right? 0, iterator I, and then we have iterator j, which is also pointing to this 0. Now we know why this size minus I minus 1 is there. This is clear, right? Now this j will be compared with j plus 1. And then what we will doing, we'll be swapping them if j is greater than. That means this will be 2 and 10. Then our j will be incremented, and this will be pointing to this new j, right? This will be our new j. So 10 and 3 will be compared. So these will be swapped. We have 3 and 10. Then 10 and 4 will be compared. We have 4 and 10. Then 4 and 1 will be compared. Then we have 1 and then 10 and 1 will be compared, then we'll have 1 and 10, and then we have 10 and 9, then obviously we will be having 9 and 10, then 10 and 0 will be having 0 and 10. So once this entire iteration is done, wherein we will be swapping these elements, so after one iteration, what will be our value? It will be 2, then 3, then 4, then 1, then 9, then 0, and then 10. So this will be after one iteration. That means this entire for loop has been exhausted once. So now after that, the next time I will be incremented, and that will be pointing to this one. And our j will start again from this pointer, and it will be compared with this. 2 and 3 will be compared, nothing will happen. 3 and 4 will be compared, nothing will happen. 4 and 1 will be compared, and therein the swap will take place. So that means 1 and 4 will be swapped. 4 and 9 will be compared, nothing will happen. 9 and 0 will be compared. Now swapping will occur. That means 0 and 9 will happen. And then this element will not be compared because of this condition. Size minus I minus 1. Okay, so this is the implementation of bubble sort. Now let's go ahead and we will implement it. Obviously, this implementation this might seem to be language agnostic. So we will be implementing it in C, and the IDE that we will be using is code blocks. So now as you can see that we have this method, that is, or function, we have here this function which is bubble sort, which takes an argument as array and size, and then we have these two for loops, nested for loops, and here the swapping will take place if it is greater than, if j is greater than j plus 1. That this is our bubble sort. Now therein we have another function, that is print array, wherein we will be just printing our elements. That is, we have an iterator, that is I, and it will loop around the length of the array, and one by one we will be printing them. Okay, this is the print array method. And then we have our driver method, wherein we just have the static array 14, 17, 8, 19, 11, and 2, and then we will check the size of the array, that is with the help of size of operator, and then we will print our array before the sorting, before we applied sorting, and after that we'll print a message that after sorting what happened, what was the array. Okay, and in between, while we are printing it, in between we have this bubble sort method which will be called, okay, just to sort the elements in the array, and then we'll be printing them. Okay, so now these are the three methods, that is bubble sort, print array, and our main function, that is our driver method. Now let's build and run this program at the same time. Okay, now before sorting the array, our elements were 14, 17, 8, 19, and 2. And after we applied sorting, our elements are 2, 8, 11, 14, 17, and 19, which are in sorted manner. So in this way, we implemented bubble sort with the help of C programming language, and the editor which we used was code blocks. Now let's talk about the time complexity of bubble sort. Now, if you can observe that we are using two nested loops, right? For and inside that again we are using a for loop. So it's quite obvious that it will be order of n square, right? Because one of the for loop is traversing from 0 to n, right? That means all the n elements are covered, and for every element that is starting from 1, 2 to so on to n, the first comparison that will happen for this first element will be big of from 0 to n minus 1, then 0 to n minus 2, and so on to 1, right? So if you can observe, right, that we follow a pattern and this boils down to big of n square, right, in the worst case. Now in the average case, it will be big O of n square again, because even if half of the array is sorted, still we are going to compare it with all the other elements, no matter if half of the array is sorted, right? So in average case, it will be again big O of n square. But now the thing is, now you might argue, right? If our array is sorted, in this case, that means 1, 2, 3, 4, 5. Our array is sorted. And now what we are going to do, we are going to compare all the elements with the rest of the elements, right? But in this case, right? If we modify our algorithm or our implementation by using a simple flag variable, I will go back to the implementation, right? Now, what I'm going to do here, I'm going to initialize a flag variable and I'm going to initialize it with 0. Now, if our array is sorted, right, that means 1, 2, 3, 4, 5, all the elements are sorted. That means this condition will never be executed. That means there will be never a case where j is greater than j plus 1. And if I will say after what happens if somehow if our array is not sorted, right? In that case, it will go inside this and I will change this flag to 1, right? But in a sorted case, it will never go to this condition, right? After this for loop is executed once, what I will do, I will just check if my flag is equal to 1. If my flag is equal to 1, that means our array is not sorted and I will continue. Else, what I will do, I will continue, right? Else, I can say break, or you can just write it like this: if flag is equal to 0, then break. That means no need to check for the rest of the elements, and we will be out of this outer loop and we will be boiling down this time complexity to big O of n. Okay, so that is what is written in here. The best case when we modify our bubble sort, it will be big O of n, right? So this is all about time complexity. Now let's talk about bubble sort space complexity. Since we are not using any auxiliary memory, right? Like auxiliary memories can be in the form of what? Stack, can be a queue, it can be another array, can be a string, can be a linked list. So since we are not using any of these auxiliary memories, that means the space complexity of bubble sort is constant, that is big O of 1, right? In the implementation, if you can remember it, right, we didn't use any of these extra spaces, right, in the form of stack, queue, array, string, or linked list. We didn't use it, right? So that is for the same reason the space complexity of bubble sort is big O of 1, that is constant. Now let's talk about bubble sort analysis. Now, if you observe carefully in the array, right, let's talk about this array: 10, 9, 8, 7, and 6. So this is our array, and this is in descending order, and we want to arrange this array in an ascending order. So in worst case, when we talk about worst case, number of comparisons required, right? the number of comparisons that are there are n square, big O of n square. Now, why this is n square? Because every time when this, when our j that is at this location and j plus 1 that is at this location, both of these will be compared. Now, if it is less than this, then they will be swapped. So we have 9 and 10. Then again they will be swapped. 8 and 10. Then again it will be swapped. 8, then 7 and 10. Then again they will be swapped. 6 and 10. So this is what happens every time in the first iteration. The largest element that is there is at the end of the array. So this is how bubble sort works. So these are the number of comparisons. That means we are comparing them one by one. 9 with 10 with 9, then 10 with 8, then 10 with 7, and then 10 with 6. And this is how it happens. So if you talk about the worst case time complexity in terms of number of comparisons is big O of n square. Now it might be obvious to you guys that the comparisons is n square, and after that we are swapping these. So 10 was swapped with first with 9, and then 10 was swapped with 8, 8 was swapped with 10, 7 was swapped with 10, and finally 6 was swapped with 10. So if you observe, every time that 10 was swapped with all the elements, similarly 9 will be swapped with the rest of the elements. And same thing happens for 8 and 7. So in the worst case, when you talk about number of comparisons that are there and the number of swaps that are there in bubble sort is big O of n square. So I will just erase everything on screen. So in worst case, this is big O of n square. And in number of swaps, in worst case, this is also big O of n square. Now, if you talk about stability of bubble sort, it is a stable algorithm. That means if you notice that the condition wherein we were swapping them is the array of j should be greater than array of j plus 1. Only then we will swap, because we are swapping only if they are greater than, right? J is greater than j plus 1. So when they are equal, nothing will happen. So stability works in this fashion. Let's suppose you have this 10, 8, 9, or you have another 10, then you have 9, then you have 6. So now what stability is, that you can either sort it in this way or in this way. Let me tell you the first way first. The first way can be, so if you talk about this and you're trying to sort them in an ascending order, so it will be 6, then 8, then 9, and then 10 and 10. So let me represent this 10 with 10 and this 10 with 10 dash. So 10 and 10 dash, right? This is already sorted, or it can be 6, 8, 9, 10 dash and 10, right? Still, this array is sorted, right? So in both these cases, right, the array is sorted. But what happens in this case, right? Let me just put it again. What happens in this case, the relative positions of this 10 and this 10 is changed in this case, but it remains same in this case, right? This is case number 1 and this is case number 2. So bubble sort works in this way, that only when they are greater than the next element, that is 10 is greater than, only then they will be swapped. So we can be sure that after sorting this array, the relative position of this 10 and this 10 will be saved and they will be preserved, right? So this bubble sort is a stable algorithm. But now what about this in place and out place? So since we are not using any extra memory, right? We didn't use any extra memory in the form of array, stack, linked list, or queue, right? Or even string, right? We didn't use any of these extra memories, and we swapped this array within the array that was given to us. So that is the reason why this bubble sort is an in place algorithm. Okay, that's it. Okay. So let's reiterate. So big O of n square, number of comparisons, number of swaps, big O of n square. It is a stable algorithm, and finally it is an in-place algorithm.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.